If your Power Query refresh suddenly breaks, it usually feels random, but it's rarely random. Most failures come from three quiet changes: column names shift, data types drift, or the source shape changes just enough to confuse your steps. The result is the classic refresh error, or worse, a refresh that works but produces wrong results. The good news is you can make your queries resilient without rebuilding everything. You just need to understand where Power Query is brittle and how to add a few protective patterns. In the next minutes, you'll learn how to diagnose the exact step that fails, how to fix renamed columns without rewriting your whole query, and how to stop type changes from breaking merges, calculations, and loads. You'll also learn how to handle missing columns, extra columns, and files that arrive with slightly different headers. Once you adopt these habits, refresh becomes boring again. Next step. Start with one rule. Don't guess. Find the first step that fails. In Power Query, errors often show up at the end, but the cause is usually earlier. Work top to bottom and look for the first step that turns from a normal table into an error. If the query still loads but results look off, check the applied steps for warnings, type icons that changed, or columns that disappeared. A fast technique is to temporarily disable later steps. Remove them only if you must. Another approach is to duplicate the query, then delete steps from the bottom until the error disappears. The last deleted step is your suspect. Also pay attention to steps like change type, renamed columns, and removed columns. Those are the most fragile because they depend on exact column names. Once you identify the failing step, you can choose the right fix: rename mapping, dynamic column selection, or safer type handling. Next step. Let's talk about renamed columns, the number one cause of broken refreshes. Power Query steps store column names as exact text. So if customer name becomes customer name or client name, any step referencing the old name fails. The simplest fix is to update the rename step, but that doesn't scale when you have multiple sources or frequent changes. A better strategy is to create a small rename map table in Excel with two columns, old name and new name. Then Power Query can apply that mapping during refresh. This turns a brittle manual rename into a controlled translation layer. If a column gets renamed again, you update the map, not the query logic. This also helps when you combine many files where headers aren't consistent. The key idea is separating business logic from header cleanup. Your later steps should reference the standardized names, not the raw incoming ones. Next step. Here's how the rename map pattern works in practice. You load your mapping table as a separate query. Then you turn it into a list of pairs, like old, new. Power Query can apply that list using a rename function. The important detail is error handling. If an old column is missing, a strict rename will throw an error. So you want a rename that ignores missing fields. That way the query still refreshes when a column is absent, and you can decide later whether that missing field is acceptable. Another practical step is to normalize headers before mapping. Trim spaces, remove hidden characters, and standardize case if your source is inconsistent. That reduces phantom mismatches like a trailing space. After renaming, add a quick check step that confirms your required columns exist. If not, fail fast with a clear message instead of a confusing downstream error. Next step. Now let's tackle data types. The change type step is convenient, but it's also a common failure point. If a column that used to be numbers suddenly contains text like NA, Power Query may throw a conversion error. Even worse, it can silently turn values into nulls depending on the conversion method. The fix is to treat type conversion as a controlled operation. First, delay strict typing until after you've cleaned obvious issues like blanks, placeholders, and mixed formatting. Second, use conversions that handle errors intentionally. For example, convert with a try otherwise approach so bad values become null or get flagged into an error reason column. Third, be careful with dates. Different systems export dates as text, serial numbers, or locale-specific formats. If you set a date type too early, refresh can break when the format changes. The goal is predictable typing. Next step. A strong pattern is type with guardrails. Instead of one big change type step, apply types only to the columns you truly need, and do it in a way that won't crash the refresh. If a numeric column can contain commas, currency symbols, or spaces, clean it first. Remove non-numeric characters, then convert. For dates, parse explicitly from text when needed, rather than relying on automatic detection. If you're merging queries, align types on join keys before the merge. A text key on one side and a number key on the other can cause mismatches that look like missing data. Also, avoid automatic type detection when combining files, because different files can infer different types. Set types after the combine step, not inside each file's sample transformation. That keeps your logic consistent across the whole dataset. Next step. Another common failure is missing columns. Maybe a supplier removed region, or a system stopped exporting discount. If you have a removed column step, Power Query expects those columns to exist first. If they don't, refresh fails. The safer approach is to remove columns by keeping what you need, not deleting what you don't. Choose columns can be configured to ignore missing fields, which makes it much more resilient. The same idea applies to reordering columns. Reordering is cosmetic for most outputs, but it can break if a column disappears. If you must reorder, do it at the very end, and make it tolerant of missing fields. Also consider adding missing columns back as nulls when they're required for a downstream model. That way, your output schema stays stable, even when the source is incomplete. Next step. The opposite problem is extra columns. A new export version adds channel, campaign, or some audit fields. Extra columns usually don't cause errors, but they can change type detection, slow refresh, and clutter your model. Again, the keep what you need approach is the cleanest. Define a required column list and select only those. If you want to allow optional columns, treat them as a separate list and expand them only when present. This is especially important when you combine files from a folder. One file with extra columns can change the combined schema and break later steps that assume a fixed set. A practical technique is to standardize the schema immediately after combining. Select required columns, add any missing ones as nulls, then apply types. That gives you a stable contract between the messy source and your clean output. Next step. Folder-based queries deserve special attention because they're a perfect storm for refresh errors. The combined files experience uses a sample file to generate transformation steps. If later files differ, those steps can fail. The fix is to make the transform sample file logic more defensive. Avoid hard-coded column positions, prefer column names, and make name handling tolerant. If headers sometimes start on different rows, detect the header row based on a known label, then promote headers. If some files include extra blank lines, filter them out before promoting headers. Also, consider filtering the folder to only include the intended file pattern, like a specific extension or naming convention. One stray file can break the entire refresh. Finally, log which file caused the error by keeping the source file name column through your transformations. That turns debugging from guessing into a quick check. Next step. Let's cover refresh errors that look mysterious, like the column X of the table wasn't found, or we cannot convert value to type. These messages are clues. A column not found error usually means a rename, remove, select, or expand step is referencing a missing name. A cannot convert error points to a type step, a custom column calculation, or a merge key mismatch. When you hit these, isolate the step and inspect the column values right before it. Look for unexpected placeholders like dashes, spaces, or words in numeric fields. For date issues, look for mixed formats in the same column. For expand errors from nested tables, it often means the expanded table has different columns than expected. The fix is to expand dynamically or expand a safe subset. The mindset is simple. Error messages tell you what assumption broke. Next step. Now, make your queries self-checking. This is how you prevent silent failures. Add a lightweight validation step after you standardize names and before heavy transformations. Check that required columns exist. Check that key columns have acceptable types. Check that row counts aren't 0 when they shouldn't be. If a check fails, return a clear error message that explains what's missing, like required column region not found in source. This saves you from hunting through 10 steps later. Another helpful idea is to create a data quality query that reports issues instead of failing the main load. For example, it can list files with missing columns, or counts of conversion errors by column. That way, your business report can still refresh, while you get a separate diagnostic output to fix the upstream data. Next step. A big reason people get stuck is step order. Power Query is basically a pipeline, and the pipeline should go from messy to stable. A reliable order is connect, filter to relevant rows, normalize headers, standardize column names, stabilize the schema, then clean values, then set types, and only then do merges, calculations, and grouping. If you merge too early, you multiply problems because join keys aren't clean yet. If you set types too early, you create conversion errors before you've removed junk. And if you rename late, you end up rewriting many steps. Also, keep transformations as modular as possible. If you have a complex query, split it into staging queries, one for raw import, one for cleanup, one for business logic. That makes failures easier to locate and fixes safer to apply. Next step. Let's bring it together with a practical recovery checklist. When a refresh fails, first identify the first broken step. Second, decide which category it is: name, type, or shape. Third, fix it with the right pattern: mapping for names, guarded conversions for types, and schema stabilization for shape changes. Fourth, add a validation step so the same problem is caught earlier next time. Fifth, document the contract of your output table, required columns, expected types, and key rules, so future changes are intentional. This is what separates a one-off fix from a durable solution. If you build queries like they'll be refreshed by someone else on messy data, you naturally choose safer steps. That's the mindset that keeps Power Query reliable, even when the source keeps evolving. Next step. If you want fewer Power Query surprises, focus on two habits: standardize early and make assumptions explicit. A rename map gives you control over shifting headers. Guarded type conversion prevents one bad value from killing the refresh. And schema stabilization, keeping required columns, adding missing ones, and ignoring extras, keeps your output consistent. Use validation steps so errors become clear messages, not detective work. If you'd like more scripts like this, subscribe. And for a quick check-in, leave a comment with your most common failure: A, renamed columns, or B, type conversion errors. Subscribe to keep optimizing your workflow and get back more of your time.